As we all know, 6G technology is the most emerging, exciting communication process which would influence the future development. On behalf of IEEE Vts Sbc Nssce, I welcome each and every one of you to this session. Wishing you all to have a fruitful session. Thank you. No further delay, we can move on to the session. Over to you, sir.
Thank you. Thanks a lot, first of all, for giving me this opportunity to present myself and also the topic of 6G. Can please let me know if everyone can audible?
Yes, sir, audible.
Okay, okay, thank you. So, can someone help me? How can I make a full screen here? Okay, yes, from my computer. Okay, I think it's okay now. Yes, can I start now?
Yes, sir.
Okay, thank you. So today I will talk on 6G vision standardization, technical challenges, standardization, and implementation. So here the main idea is to give the roadmap about 6G that will going to be happen in 2030, but that is the time when we are saying that 2030, but real deployment will can be seen around 2032, 2034, around the same, but we are in now in 5G. So we are in the 5G era. You can see that most of the countries are already deployed, but still some of the services is not available. Same roadmap we will follow for 6G as well. So before start the presentation, it's important to see that how we started our journey from 1G to 6G. What are the main causes why we need to move our generations? So it's very important to see that in telecommunication, which going a bit slowly. After every 10 years, we need to change the generation. If you compare with computing world, it will bit faster than the telecommunication world. So we, after every 10 years, we will change our generation because of the certain reasons, which I'm going to show in this slide. And you can easily see the meanings of the color mentioned at the bottom of the slide. So in 1980, when we start our computing world, most of you don't know, maybe you born after 1980, but the people who are already on that era, they know that we have the networks, and APRANET network was very few which is available in states. Then we have human machine interface. On that time, you can see very devalued, and a lot of talk on the hardware and the operating system. And then after 10 years, when we start into our real network, Microsoft still haven't come into the picture. I think 1992 when Bill Gates had first window, but still on that time you can see that APRANET now convert into very few bits WW with World Wide Web, and the network start getting some important. And you can see that our human machine interface also get important because we already develop a kind of mouse and a very basic keyboard on that time. And then in 2000, when our computing network now start integrating into our telecom world, because still here everything will be wired. We don't have any wireless connection. We don't know about telecom. We don't know about Wi-Fi. But on that time in 2000, our computing world now enter into our telecommunication world, and a lot of mobile operator, not a lot of on that time, but whatever available on that time, they start thinking that, okay, we need to connect our network with the computing world as well. So we cannot live in isolation. So you can see that telco systems start emerging. This world some appear in 90s, in 2000s when we first time telco start. And you can see the bottom also gets some valued and devalued as well. And Nokia, very famous 3320 handset was very famous, was came into the market on that time.
Sir, are you changing the slides?
No,
Okay, sir.
but I'm on the same slide. Can you see my slides or not?
Yes, sir. We can see it.
But what happening, because I'm doing some animation, you can see the animation coming, going or not.
No, sir.
But can you tell me what you looking at now?
Sir, we can just see your screen with the first slide and nothing else.
No, but can you tell what you looking at the first slide? At which point you are
6G
now?
vision requirements, technical challenges, standardization,
No, no,
implementation
no,
for
no, 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 no,
2023.
no, 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 no. It's not
Okay.
correct.
Now ODC from 1G to 6G.
No, no, it's not correct. Oh, this is a problem. Then let me. I think I need to share whole window. This is a problem with the. Okay, can please let me know. Now I'm sharing whole window. What are you seeing now? You're seeing something?
Yes, sir. Now it's visible.
Now,
ODC from 1G to 6G.
and now you can see 1980, 1990. This.
Yes, sir. We can see that.
Okay, okay. Please let me know because I was showing this. Okay,
Sure, sir. Thank you.
so sorry for that. So now I'm sharing whole window. Now I think it will be more easy. So in 1980, you can see that we start with the. So I have to start again. So APRANET was their network. So we have human machine interface. So you can see that on that time, more or less, the more value will be on the network. And then in 1990, you can see we start developing the keyboard, mouse, CPUs. So this era will get bit of valued, and human machine get value because we have already mouse and keyboard at that time. And you can see APRANET will be now convert into WW. And then in 2000, when our mobile operator now start realizing that they want to be a part of computing world, so they start with a telco system, and Nokia proposed on that time in 3310 new handset on the first time, and we start communicating wirelessly on that time. And then in after 20 years, now you can see telco now system into convert into clouds, web cloud. So a lot of operator now using cloud, a lot of happening in web cloud. So everything now talk about Google Cloud. You have AWS, service, Amazon. So cloud is happening, and you can see that all the bottom one is also get valued as well. And then 2030, our type of cloud will be changed into data centers. So we have data centers now, but this will be, you can see more sophisticated data centers will be appear, and all the application, your DSPs are running on the data center. Your gateway, your network will be like a dump pipe. It's just for the passage of your data, but mostly processing will be done at the cloud center. And then you have the virtualization. A lot of virtualization will be done. So hardware will be a very limited. We do a lot of virtualization, and your human machine interface will be like a holographic kind of thing, which you can see, you can use anywhere in outside your hand or outside in the air. You can dial it. So you can see now that we start our journey. The most important is the upper part. We start with the APRANET, and now we end with the data centers. In next 10 years, with all the processing, your DSPs are running there. And similarly, your human machine interface now will be more holographic. So this journey is take around 3 decades or more than 3 decades when you are starting in 1980 to the telecommunication. Also, the important thing to note here that we start converging toward computing world and the communication. So we cannot work isolation with the computer. We need to do a lot of computing strategy here. So a lot of things going to be happen here, not purely telecommunication. Okay, can you please tell me if you can see my next slide? Oh, good. So I think it's good. Okay, so along with this architectural changes, we also have happening in our device level also. So if you can see that we started with very big handset, we have a bulky, you can see the transistor size are around 12 to 13 nanometer, very big transistor size, very power efficient system. You can prolong its battery for a long time. So as you can see, we move toward left to the right. The size of transistors are getting smaller and smaller, and your complexity of your electronic getting harder and harder. But again, with this, you also get a lot of benefits. So in one device, you have cameras, you have radio, you have your TV, you can do gaming, everything. But the past, for every hardware, you need a separate hardware for that. For TV, we have different. For we want to be video, you have a VCR, the decoder for camera. But here you can see all in one device. But complexity will getting very higher, and the transistor size are getting very smaller and smaller. So this is also the factors which is also affecting why we need that, because our use cases are changing, data rate requirement are getting higher as well. So you can see that we are around touch and gesture, which is mostly in this 5G, but in the 6G you can see more tactile, where you can senses, you want to transmit not only voice or video, you want to sense all five human senses, feel, touch. You also need to transmit that over the air. So that is the way we are heading toward. So for the 6G trends, all the companies are agree to have these four factors. We should have connected machine as the main users along with the human being. And then we have the tool coming from the computing world. Artificial intelligence will be a part of your communication world, voice communication. We use a lot of optimization with the help of artificial intelligence. And then the openness of your mobile communication. So this, we want to make your system open. We don't want that one vendor software work on any specific hardware, or every specific hardware work with a certain software. So it should be open. So this means any hardware work with any software, and any software work with any hardware. So you heard about Open RAN is one of the direction toward this initiative, but today I will not talk on this because of time constraint. And then we have a social and mobile communication. It's very, very important. This thing you cannot see in 5G, but this you can see in 6G. Social goal that we need to define some ethical liability, ethical boundaries between the devices and also the human being, because a lot of data is sharing, a lot of apps are developing, a lot of new tools are coming out there. So there should be a social goal, and this is a big generation gaps between the kids which are born in this era, with the gap which people born in 1980s and 70s. So this is a social goal which we need to maintain, and also to propose and to standardize it. So this is also quite new topic, but these two I will not discuss in detail in this presentation. I will discuss first two. As I said, we don't have enough time to go all this today. So to go into the internet past, present, and future. So start with the past. If you can see that till nowadays, mostly services we are using web services. We use a lot of application. We use multimedia. In multimedia, we use gaming, Facebook, Twitter, and on that, the requirement mostly with the data and voice. Mostly we call person or we send messages. So here we need a medium or low latency, medium readability, and medium throughput. So everything is medium. Lives are going well because our use cases are quite simple. They are not so data hungry intensive courses. So, but if you go to the 2030, till now until 30, so most of these use cases are defined in 5G era. So, but it will still going, as I said, that in 5G we already deployed, but still some of use cases are still not applicable, but that will be, you can see in coming year. But here you can see that some tactile internet, you can see VR, XR is coming now. That is the era of 5G. So a lot of virtual realities things are coming. You can see 3D movies like in these avatars can coming. So here we need very low latency, high reliability, and high throughput. So you can see that the requirements, the key value indicator are getting changing. So, but in the 6G, which is, I said, to 2030, but again, I believe it's more on 2040 because it's just the vision. Here we have new media, which is called holographic kind of communication, where we want to transfer our human body avatar from one place to the another. We need new services, for example, teleports. We need new infrastructure, like terrestrial infrastructure we need. So these are the use cases which are changing. With each use cases, your requirement is changing. Along with tactile, you need holographic, where you need very low latency, very high reliability, and high throughput. So out of this, low latency is not easy to achieve, because that is, we are dominated mostly lot of factor when you transmitting your single packet or bit is traveling all the way, coming out of your phone in the air base station, then it go out the wires, core part, and on the other side of the server, and then it reach to your family member or other part of the world. So this is the hardest part, is to achieve the latency. High reliability is, from my side, is not so difficult, and throughput, you just have to increase the bandwidth. You will get we go for the higher frequency, millimeter wave, terahertz you achieve. But out of latency is the highest difficult to achieve. But again, a lot of work already started, and people are doing from last 10 years also. But again, it's not an easy task. So what happen if you can let me hide? Yes. So in 1G to 5G, mostly we can achieve a lot of things, which is mostly fixed or partially movable or dynamic. For example, when you make the solutions, we almost see downlink. If you want, this is your base station. For us, we always look at the mobile node, or from the mobile node to the base station. So mostly these two nodes dominate our networks. So along with now in 5G, we have some kind of this IoTs, vehicular. So, but most of the solution which we develop in the literature, in the paper, or in the standardization on these two nodes, either uplink or downlink. So this is quite a bit narrow micro. But if you go to the 6G, so we have two world now. We have the real world, which is coming from 5G, and we have the virtual world, which is a new kind of class which is going to be happen in 6G. So you can see that here we need to optimize both world, either real and virtual world. Whatever happening in your real world, the digital copy is running into the virtual world. This is around 24/7 kind of data which is coming and going. So optimization is quite important. So you can see that is quite hard. If you're moving from 5G to 6G, the challenges will be high. Here you can see you need to achieve a certain kind of throughput, certain kind of latency, reliability of these to both worlds. So here everything will be dynamically, because everything dynamically change. The only speed of the light will be the fix. So for me, that is the future, where you have a lot of virtual world, where the virtual world you have a lot of use cases, digital twin, digital twin, AR, XR, extended reality, and it is also a combination of everything. It's not only what you need to learn from the data which are coming via sensor from real world to the virtual world. So here a lot of big data processing, artificial intelligence. Then on top of this, you need to propose a new security framework, because everything is open. So this is also, you can see a lot of things are mixing of the world, from communication world, mathematical world, and the communication. So it's kind of multidisciplinary kind of research you need to be done to make the reality of 6G. So why we need machines lot of in the 6G? Because machine can do everything which human cannot do. We have, by birth, we have some physical limitation, the way we create. Like for example, we cannot audible between more than 2000 hertz, but we can create machines which can go beyond that. Similarly, we cannot visible around 780 nanometer, but we can create machine which can do. So machine we need to create to do what human cannot do at a limited time, but machine can able to do a lot of things. So for that, one of the topics which is very important coming from the computing world is the AI. Some of you already have seen that, and a lot of work have been done. So, but still, there's a lot of things need to be done at 6G because we still don't know which part is going to be standardized, because a lot of companies, papers are coming, but we need to standardize something like we are doing in normal communication. So everyone in the world, if they're going to make the product, they follow the same standard, so that product can be used in all the country. Otherwise, everyone make their own product. If you move from another country, it will not work there. So mostly AI work very good in upper layers, network layer or application layer, but now the more emphasis is how we can use at the bit level or symbol level. So if you see our communication from the Second World War till now, when Shannon theory born, so mostly they use inferring communication very sequential wise. So we have a source, we have the transmitter, and then we kind of noise in the message, and the receiver, you remove the noise and it will remove to the destination. So a lot of work already done. We have very nice closed form expression for all of them. So we are very experienced in this work because that's what we are doing from almost 60 and 7 decades. So we know how transmit behave, what are the waveforms, what are the noise, how to remove them. We have a lot of receiver cancellation algorithms of noise. So we are very expert in these, and we have very nice waveform and closed form expressions for them, and which we can good very nice curves will achieve. So, but what happened in the machine learning technique? So I will call machine. I will not go into detail of different algorithms. So this is a more technical. My idea is to explain you the actual theme. So we have a transmitter, and so here we have the learning curve. So it's like your father and son relationship. So you need to teach your kid at certain time, but once he become like 17 or 18, so he have enough brain to make their own decision. So we don't need any black line here after certain time. So this can make their own decision. You can see why while doing this, you get a lot of benefit. You don't need to send the feedback all the time. Like in this case, here he can make their own decision. But again, whenever you make your communication system, always think about nature, how we human behave. So your communication is nothing than that. All communication, the things are make like human beings. So when you are a kid alone in the world, he should be vulnerable with the different diseases. So he need to protect them. So he can be sick, he can be tired, he can be happy, the same thing happen with your machine learning algorithm. So in the communication, we give a specific name to these things. For example, we need to secure them, secure because of their vulnerable data. So as a human being, we need to eat medicine. So if you can see the nature and the way we behave, your communication world is exactly the same. But if you see communication as a communication, for the beginner, it's difficult to understand because it's difficult to see grab that knowledge. But if you see the nature and then apply it to the communication, it's quite easy. Here, everything is closed form expression, but here something we cannot make a mathematically world. We cannot make closed form expression. So that's why we need to optimize it. So you have to understand one thing, that machine learning cannot beat mathematical framework if it has a closed form expression. Closed form expression always give you the best performance than machine learning or artificial. Artificial intelligence is very good when you cannot achieve mathematically closed form, then he can optimize much better. So there's a lot of new classes are coming. For example, if you have a human being, it's like your kid, so your kid don't understand at some point, like he's 21 and you thought he's very efficient, but still he needs some guidance. So he has some teacher who can help. That kind of machine learning technique which we are coming in 6G is called hybrid learning. Hybrid learning, that you take the help from the machine and all from the human decision. So same thing happen with the human. So continuous learning, federated learning. If you map them to the human body, a human being, that what a kid or human can do, you can come up with a lot of new learning technique. Okay, I will not go into detail because it's a long topic to discuss. So let's go to the next. So the same thing. So now come back to the communication world again. So you can see that now we have to teach them with a lot of data set, but for each data set, you need to come up with a new thing. So for example, again, if you see the example that a person is born in India, if he leave India, he go to Europe or go to state, he don't need that enough data set, but machine need, because he's a human being. He's have this ability. So if you see in that manner, you can propose novelty here. So one of the lack of interoperability. So you can see that we cannot use same data set for everything because they are not efficient like human beings. So we have need to make a new data set for everyone to teach. So that is the lack of interoperability still available, and they are not open exchange. So this means you cannot reuse again. So we need to all the time we need a new data set to teach them. So that is the new challenge which we need to fix in the 6G. So your machine learning can be run at your device level, like as a kid. It can be run at your learner, your masters can be your parents, or in this case the base station, or at the core part, or at your transport. So everywhere you can learn machine learning, and then you need to develop your algorithm how to make them efficient. It can be a device level, can be a localized level, or can be a end-to-end AI. Okay, so now let's come to the digital twin. As I said, digital twin is one of the very, very important use case for the 6G. So you in the digital twin is not a new idea from this industrial. It was there for many years, but very new in our telecommunication world. So you just tune your one device physically to the virtual world. For example, you have a car running on your outdoor, your one car model is running at your mechanic. So you don't need to come to your mechanic all the time, because the data is coming. So your mechanic can know that what is going to happen. If something wrong with your car, he will just do the software update and your car working correctly. So this is mostly happening in the new cars, which is mostly work on electric. Tesla, Volkswagen have this ability. They already have a digital twin, but not sophisticated, but they are doing this now. But in future, you can see more and more. And similarly, for the human body, you can create a digital twin as well. So I just give you a simple example of digital twin. The people who are not so much familiar with this technology, very basically like a child toy example, so you can understand. Just imagine we have the buildings. We are in the city. We start building. Our civil engineers have the map and they start making building. Okay, it's done. And then after building, we need to put the kind of this infrastructure. Infrastructure can include your pipe, electricity, trees, your solar panel, etc. Okay, this is done. Then we start putting roads for the different mobility. So we put the ships are moving, your cars are moving. So that is happening nowadays. Our cities are like that till 1915, you can say like this. All the cities in the world, especially if we talk about first world countries, mostly they are built like that. So now after 1915, they are called smart cities. You heard about this term maybe before, but smart cities, what they do till here, now they start putting a lot of internet points, Wi-Fi, that your whole city is connected via the smart city, a lot of sensor and which we call digital layer. So this is layer above our civil engineer. So this is mostly done by, you can see that this electrical or electronic network, they did that. And then afterward, now the new things are coming in 5G. The era is called virtual layer. On top of the digital, now they call virtual layer or digital twin. So what happened? They want to create whole city into a virtual world. Also, why they were doing this, I will show you. I will tell you in the next slide what is the benefit. But for here, just to understand that we start from the building, infrastructure, mobility, very new after 2015, you can see, or 2010. I don't know the exact number when we start building the world. And then you have this virtual world, which is quite after 2018. You can see this is a new things they are going to propose in our cities. Okay. Now, why we are doing this? So we already created the virtual world in the last slides, if you remember. So, and these sensors, which we call smart city, we have a lot of sensors and plus the satellites also sending data. So real-time data is coming. the digital twin data is continuously coming, and with this data we're going to make our city smart. We can make a lot of decision that okay, what happening to the next, but where this car move, either here or here, because we have 24 data of it. So stakeholders of such city planner or construction team can turn on simulation and data analytic. So data analytic include everything, which big data analysis, AI, other thing, and then we're going to implement, and then we're going to optimize. Okay, then we said, okay, in future I don't need this because there is vulnerability, so I can remove this to here. I mean, just giving you one of the example. So this is a typical urban planning, but the idea is same. You can do exactly same with your telecommunication world or telecom world or computing world. All of this start with your infrastructure and with the twin. So this is a bit more detailed picture. You have physical, as I explained you, and you have a cyber physical city, and you can see that. Now I'm going to more communication. You need very high capacity link, low latency, and you can do all kind of manipulation and go to the same loop again. And this is 24/7. This is what you can see in the digital twin. And this is one of the important use case of your metaverse application. Your metaverse also in the same way it work. So it's more on the technical side. People want to do more research. This you can see that we have a digital world, the physical world. So the called cyber physical continuum, where we have connected machine, internet of senses, because when you go to metaverse kind of thing, it's not only voice or data. You need to taste, you need to feel, you need to touch. Of course, not possible nowadays, but in future you can see that part as well. You see this is a past world and this is your future. You can observe and you can break that part. So in the future, you can see that these are some new services are coming. Media is coming, industrial internet, tactile and vehicular. For media, we started with text and we end up with a holographic. So we need a very sophisticated kind of technology to fulfill that demand, because here latency is the very important for different sector. For media, latency should be around motion less than 20 milliseconds to see your picture. Similarly, for the industrial internet, the latency will be around 25 to 10 millisecond because of the different use cases. You can see that cars are coming, connecting your computing, so sensors. And similarly, tactile end-to-end latency should be 1 millisecond. For vehicular, your latency should be around 5 milliseconds. So here, the main emphasis is that we need to decrease the latency in these are the 4 important vertical sectors which we have in the city. So that is the main target, and how to do that, that we need to going to propose and also going to investigate different technologies to achieve that number. So holographing is one of the technologies, is the subset of your digital twin also. So for example, if we want to teleport this human presence, so we need to map it according to the height, the real height of that person, and height will be different in different country because of the physical appearances. And to transmit that, we need a very high bandwidth, which is in terabyte, because we want to the 6 degrees, not only 3 degree, we want is 6 degree, we want to transmit, and plus we need to transmit with the senses also. So to move to send this kind of information, we have to move from qualitative to the qualitative digitalization. Quantitative digitalization mostly useful for text and voice. That's what we're doing in 1G to 5G. But here for qualitative, we need a different digital communication techniques. Here we are transmitting byte by byte. When you transmit your packet, you send byte by byte, and if a whole packet is transmitted, if a byte is lost, so you can understand you need to retransmit whole packet if you get your bit error rate. But we cannot do here. Here no retransmission is required if a byte is lost, because we are creating this human bit with a pixel, so we just retransmit that pixel. We cannot transmit whole human being again. So that is called qualitative characterization. And this is very important because here latency is important and reliability. So they have different KPI, different matrices. So for different matrices, we use different solution. And there's just a toy example that in future, if a guy want to transmit to the holographic communication with his family, so he want to transmit vision, hear, touch, taste, and smell to his family. So this is quite hard and quite fancy nowadays, but I think in future it will possible, because when we start our communication, no one thought that we will have a Skype call in 20 years if you go back in 1980. So but still now we can able to have a Skype calls, and we can see each other, can talk. But and this will also going to be happen, but not now, but in future you can feel, taste, and touch everything. They are in the end, they are simple, our waves, electromagnetic waves. So we will manipulate with them and we can transmit over the air. And these are some numbers which we need to achieve that. And then there are some requirements which you can see in many papers and many white papers and also publications. So we need a certain number to achieve 6G as well. So out of that, I believe that which is most papers and companies are missing is a computation efficiency. I believe is quite important because we are combining both computing world. So communication efficiency is also important, along with upper green part, which is just the enhancement of the 5G. But these numbers are not confirmed yet. This is mostly on the research base, but it's not have been standardized yet. We still need to measure when we have some real infrastructure of 6G will be ready in 2030. And then what are the architectural changes which we need? So if you see the dotted line, it means a wireless connection. When you see the CPU sign, it's mostly on the computing capabilities. So if you start with the 4G, which is 10 years back, when we have cloud computing, so most of the computing part will be happening in cloud, and the core part, your base station, and UE just like a normal wireless communication. Then the term called edge computing. Why we need edge computing? Because our new use cases are coming, our cars, vehicular communication, IoT. So now computing will be done not at the core part, but out at the base station as well. So that's why we call distributive computing. So computing is distributed all over the network. So then in 6G, we have communication and computing convergence. So computing will be done at your UE as well, base station, core, and cloud. This is called splitting. Computing split our device, so we can split on the device here. But you can see that our device have not so much power. You have only 24 dBm. So when you do computing, your power will get efficiency. So a lot of work have been done on this area as well to make this more efficient. But again, why we need this? Because of new use cases are coming, like your VR application should be run on your device. Your holographic information should be running on your device as well. So that is the reason. But again, this is the vision, lot of challenges, lot of technical challenges which we need to be solved in future. So, and then along with this line, we need to create, I will go a bit faster now because I'm running out of time. So we will propose a new human intelligent kind of 5G radio, 5G base station. So in future, I want my base station, nowadays base station job is just to transmit and receive signal. But in 5G, like a human being, I want to give the brain to my base station, give the eyes to the base station, and he can talk as well. So with the help of computer vision, he can see the object and see if there is a blockage or not. And then he make that decision to the brain, which is called coming from intelligent radio or AI. And he can make the decision if it's blockage or not. And of course, he will not only transmit a normal signal, he will use natural language processing and the techniques which nowadays people work a lot is semantic communication, which we give the meanings to the word, meaning to the word, rather we just transmit a raw data 0 and 1. So that you can see that with the help of computing, we can make our base station think like a human being. We can give him brain, we can give him the eye, we can even give him the language to talk. That is what we call semantic communication. So I will not discuss into detail about how we do vision or semantic, but it's for you to see it and learn more, see how we can achieve that. But that is the vision you can see in the future. So I'll just about semantic communication. Semantic started. So we move from Shannon toward semantic because for us it's not rather how we transmit. We need to focus what we transmit. That is the main reason. So we get a semantic to the meaning 0 and 1. We don't need to send the raw bits. We want to transmit what we transmit. So throughput is not so important. Of course it's important, but our focus is what we transmit. So that is the most important. We don't want to waste the bit. So that is what is called semantic communication. So that idea was not new. Shannon know when he proposed his theory, but on that time he didn't give think about semantic because on that time there's no technologies. But now we are in the era of technologies, of new use cases are coming where we think semantic is more important. So we are using semantic a lot. So I will not go into the detail because of the time constraint. So to achieve all this, we have to go to the higher frequency. So far we are using millimeter wave, but now in future in World Conference 2024, I think next year they will going to open some more band for the terahertz. So it's a free band, but again the coverage is quite less because of high capacity. The size of the wavelength is quite less, so you cannot travel along long distant, but they are very highly data efficient. So you can use you can use inside your CPU in the chip. You don't need to wire. You can transmit with the help of terahertz communication inside your houses where you have your your Wi-Fi or in-body communication or QoS. So there are some of this application. Of course, you can use outdoor, but then you need a lot of multi-hopes things to communicate for the long distance. Mostly they are for the capacity waveforms. Of course, when you're going toward higher frequency, as I said, that we cannot decrease more size of transmission resistor about 5 or 4. I think Qualcomm's has the last CPU which you designed a transistor size of 5. So we cannot go more than that because of the limit of Moore's law. Because when you decrease the size of transistor, they start sizing becomes small. Then they dissipated a lot of heats. There's a lot of other drawbacks. So for that reason, now we are moving toward photonic kind of things. But you can see that it is happening after 7G when you have more processing is coming. So a lot of DSPs are happening, but that is all in photonic domain. So in this picture, you can see that so far material which we are using to design our RF, our base station, our phone sets is mostly from CMOS technology. But you can see that 3V is, if you know your chemistry table, is from the material, indium, metaphors, and germanium side. But you can see that after 6G, you're going toward photonic. Because this higher frequency you cannot support with the material of CMOS and this, otherwise they can burst your transistors or capacitors. So you have to go a new materials, also photonic or 3V for 6G. But again, after more high frequency, you have to go to photonic because we don't have so much. I mean, for the time being, we don't have material who support so high frequency. But for 2G, 3G, most of the component which you see in your phone set is from the CMOS materials. Okay, and then we have, so I will don't have time for this, so I will not, I will skip this, it's not important. So, okay. So about material, so I think this slide is important to discuss. So if you can see that your phone is made of many material, and this material is coming from different country, and to dig this material, we have to consume a lot of water. So to make this sustainable, we have to make sure that this material is re-engineered and recyclable. But for time being, you can see that our touch screen consume indium, and indium is mostly produced in South American country. And then you have a nickel, a cadmium, and these all which is used in battery, and they're coming from China. And then for display, you have different material, and from the chessboard, you have different. And similarly, for your speaker, so you can see the how many material we are using and how many digging of the earth we are doing, how many waste of water we are tons of water we are used to purify these things. So we have to be important for the material engineer to propose a re-engineer, reconfigurable, sustainable material to make our world sustainable, because this is one of the goal along with the technology which help people, but we need to help the our environment as well where we are living now. Okay, and something on the mathematics part. So mostly a lot of work will be done so far on capital efficiency, energy efficiency optimization. But if someone interested to do mathematical analysis, so for Shannon, this is a lot of learning now already done. So now we need to more see the trade-off between computation and computing world. Communication is coming from Shannon and computing come from Lord Limit. I don't have the time to explain that part, but just for the iceberg tip. So if you want to see, you can see there is a lot of trade-off which you can use, and you can propose new mathematical framework either with different optimization theory or using machine learning to optimize them. So it's can see in this slide, but in future you can see that a lot of we need to optimize these two world, communication and computing. And so for this some timeline, you can see that the last product which you can see in 2030, this is timeline for the 6G. This is the timeline from different organization. We are living in myself in Europe, so we are here. We are writing now a lot of 6G projects along one of these technologies, but you can see that the real 5G test will be around 2018. But still, we need to see the products, but still time. So still we are fighting with something on 5G use cases is still not deployed. And this is from the standards 3GPP, where you can see that the 6G release will be start in 2022, which we already have. So this is the part you can see 6G, but real 6G, you can see the product in there. So we are already in release 17 now, and before that is all 5G, but in release 17 of 6 on 3GPP, there is a lot of documents. If you want to test it, you can read that then on this portal. Okay, and then this is my vision about our future. I called my network the liquid system network for 20. It can shape anything like water. When you pour water in any device, you get the shape of that device. So similarly, at device level, you need some kind of capabilities. Your device can be virtualized, graphene material. Network should be no boundary. You have self-free kind of thing. You can have a lot of intelligent reflective services. Then at technologies level, you need certain technologies. You heard about massive MIMO, zero energy technology, cellular as sensors. At transport level, you need MAC, fog, DU, blockchains. So this is a thing. But these are the use cases. It will depend. You can adjustable according to your scenario. Your network should be very capable of that. And on Spectrum, we need Spectrums. And in the network, we have human, we have machines, we have digital twins kind of user, but I believe in the future. And then we have to enhance our antenna technologies also, because antenna is the device, is the only transmitting device which is going to transmit. A lot of antenna is now structured, unstructured, but they are mostly digitally controlled. But I think we have to also mechanically control the antenna, where you have self-configuration material which can adopt the physically physically structured antenna, which can make, according to the frequency, they can change the shape of antenna. I'm talking about physically, not logically. And then you have a business model for the operator, because we need to motivate them to have a business model, and insurance company as well. So thanks. That's all from my side. Thank you a lot. So if you have some questions, feel free to ask.
Thank you, sir. Now the participants can come up with their queries.
Okay.
Sir, what are the technical challenges for implementing 6G communication and how can we overcome them?
Yes, that's the good question. And technical challenges a lot as I explain you, but some of the technical challenges we don't know yet because so far we just finalized the use cases. Some of them I already discussed with you, like digital twin, e-health, cooperative report. So technical challenges always arises with the different use cases. Like if you think about 5G, on the 5G. In the 5G, we have a lot of IoT devices. We have V2X communication. On that time, we start with how two devices can communicate, how they can discover what are the protocol which we need to implement. So we did that part. So similarly, with the 6G, we already defined the use cases. Now this use cases is shown to all the public, to different university researchers. So now they are trying to propose different kind of technical challenges. So you can see there is every day bunches of papers are coming. So one of the technical challenge I just explained because I talk a lot on digital twin, how to synchronize both physical and digital world. But this technical challenges always comes when you start digging to study that use case and try to see that how we can map this to the nature and how this nature come back today, because in the end we need to make our digital world, our communication world, exactly what uh, nature can do or what human can think. Like for example, we can think, we have a brain, we have eyes, so we want that our communication technology do the same. So there is a lot of technical challenges. It's not a simple answer to give, and at different domain, either at your either your technical domain or your societal domain or your environmental domain. This is a quite long debate. It's if it's more specific, it's more easy to answer. But it's as I said, it's not easy question to answer.
Thank you, sir.
Yes, please. Yes, yes. I mean, security challenges I didn't cover in this slide, but one of the security challenges that we are talking a lot of about the openness. We talk about a lot of AI in every area. They are putting AI. So one of the main challenge for me that at which level of security we need to give to our network. Either we start at the bit level, it can be your physical layer security, or you want your information security, your network security, or you want security at your transport level, or you want your end-to-end security. So these are some of the challenges which is coming into the picture in the 6G, which is quite unique to the 5G, and we have to make sure that if this security framework need to be stable, or it can be a dynamic, or it can be adopted according to your different use cases. Just imagine that our three users are there and three users use differently. One is using normal video call, one is using sending data, and other is using holographic communication. So all these three users have to go to the same pipe to the network. So we have to decide that, because they have to form these bits, then they have to transmit to the sampling, then they have to pack it, then you have to go to the whole network. So it's very important to see at which level and which security you want to give, and also on the upper top of that, we need to standardize that which security interfaces we need to standardize to become a part of our whole network. Because if you give one security framework in one country, that should be equally aligned with other country also. So these are the few challenges according to me is quite important. Also, I forgot to mention the quantum key distribution. A lot of work have been done because security is vulnerable. Whatever you do, and it can be a branch of that. But if you go to the quantum physical security, which claim to be a very strong, it's not my area, but it's one of the security which I think that it will be a part of 6G where you use quantum distribution or quantum security mechanism.
Sir, sir, how will 6G communication find its place in like applications in the upcoming electric vehicles, like communicating vehicles and self-driving cars and all?
Yes, yes, yes. I mean, okay, with the 6G, if you can see that you're talking about electric vehicle. So the one of the, of course, 6G is a kind of communication technology, but for the electric vehicle is important that which, as you can see that in the electric vehicle, you have a lot of sensor, lot of communication modem communication system which need to be communicate outside the world. So if you see 5G is not enough for electric vehicle because the amount of data they are transmitting is not only nowadays you can see only video, only voices, but in the vehicle electric like Tesla, they have images, they need to send real-time video, they want to update their software. So I think this is only possible over the 6G network where you have high capacity link and high capacity link with a lot of bandwidth. So this is one domain which you can see at the communication domain, that you need to connect your car with your surrounding vehicles, where it's not only the vehicle in front of you but also the users which are using their handset on the pedestrian, because they need to sense that data as well, and this all data will help them to go back and to make more sophisticated decision. And on the second part, on this 6G will help on this environmental issue, because of course we don't have anything related to the gas now because everything is electric. But again, there's the challenges of the other, like when you go on the road, the friction between the road and the tire, the lining on the road, they all give a real carbon print which is affecting your environment. And especially when you have a batteries of these cars are quite expensive and are quite vulnerable for the environment. So these battery generating data, so these data have to be go to the somewhere that can be go back to their companies or the vertical with the media or automobile, where they can conduct and they can analysis that carbon print and send that back to the car, so car can make more efficient decision. That is the logical domain. But over on the physically, they need to be come up with something to decrease the carbon print at different level. So I think from my side, 6G is quite important because of this source of data, and to make more accurate decisions in the electric, especially this autonomous car.
Okay, sir. Thank you.
Hello, sir. My question is about the qualification and experience needed to work in 6G communication field.
Can you repeat your question again?
The qualification and experience needed to work in 6G communication field.
Okay, if I understand your question correctly, you want a human who need a job in 6G, what kind of qualification he need to be a 6G?
Yes,
So
sir.
if okay, if this is a question, okay, I don't think there is something new you need to read. I think the normal electrical engineer or computer scientist, because actually 6G is not the term which you use. 6G, sixth generation, it's not about communication. I explain you, this is the convergence of everything. For me, I think it's more computing than communication now, because everyone using computing world. And if you see the jobs which is available now is all the computing job. No one want pure electrical engineer or telecommunication. If you are a pure, for me, you cannot get a job in 6G era. You should be very, very good in computing world. At least you know AI, machine learning, big data analysis, software development, software management, which is more because 6G is mostly impact your upper layer, network layer, transport layer application, where I think you have the more chance from the computing world. But again, this is good if you are from the computing or communication together. But as I said, if any kind of this electrical engineer computing, again you need at the mechanical also, because you need to build antennas. So this is anyone can do who have the engineering or computing or this information technology degree. He can contribute toward 6G. Again depend which level of area he's looking. But again, it's not about communication. 6G is never about communication. It's about all the thing which is going to be inside one box, and each one have to give their own portion of contribution to make that 6G happen.
Thank you, sir.
Hello, sir.
Yes.
Sir, what will be the applications of 6G in the future of education sector?
Yes, a very good question. And this is actually one of the thing which we are doing here in Europe, also started last year, that we are have these online classes, but this is mostly on metaverse. So one of the educational set from here that we have to create metaverse classes, metaverse meetings, metaverse contribution of the courses, where is more virtualized. For example, if you are a medical student, so for them it's nice to have a whole human body in front of them by using VR XR classes. We can feel how blood can move, they can touch the organ. So from the educational sector, the way we looking at 5G, you cannot see after 10 years, maybe your kids or their kids, they will be surprised the way we live, the way they live on that time, because they are totally changed. And this thanks to the 6G, that the technology they are bringing and the innovation. So you can see that digital twin, metaverse, and the whole lab kind of environment is virtualized. So you can teach your kid more like in this interactive manner, rather you just tell them to write essays or go internet search. It is more like interactive. They can touch, they can feel the things and go into deeply. So I think that is the main from my side that which can revolutionize your educational sector.
Okay, thank you, sir.
So,
Yes.
so will this 6G affect our environment?
Hello, can I understand your question, please?
So will this 6G network affect our environment? In what sense it will affect?
No. I still Gopika. I don't understand. I understand you said 6G something that I don't know if someone helped me, because line is not so good. 6G. After I don't understand what you're saying.
Sir, she's asking whether 6G will affect our environment or not.
Oh no. That is not. I mean, as a wireless engineer, this we cannot say like a lot of people complaining that this health is not any issue, because everything, these devices which we are putting on our ears or we are using, they are already past this EMF test. So every phone which you are using, they already go to the test and they will check how many electromagnetic waves can enter 1 kilogram of your human meat. After that, they will pass. So first thing, it will not affect our human body. And because if you can see if you have a TV and you can use this infrared, that is very, very high frequency. That is much dangerous than the phone which you are using. Phone is still, we are using very low frequency. This infrared at your home is very high, but still that is not affecting. That is about our this environmental. Of course, that is will affect because we need to dig it material, and each phone have different as I explained in my slide that your phone is making from different material. For different material, you need to dig the earth. It's not only earth, then you have to use your water, and it's tons of water is needed to, I don't know the exact number, to just clean one material. You need ton of water. So we already have shortage of water, and also the politically it affect a lot because some countries have some material, some country have others. So because of certain reasons they don't want to export, then they have to go for other domain. So of course it will affect. I mean, we have a good things and we have a bad things. So we never be a free lunch. So technology can bring a lot of benefit, but again, it's a negative effect as well.
Thank you, sir.
Sir, my query is based on, can you please tell me what will be the overall challenges and at the same time opportunities of this particular kind of 6G communication technology on that of business and governments? That means I just want to know what will be the overall effect of this particular kind of 6G communication technology on the global economy like that.
Yeah, yes. I mean, as you said, as I said that when 5G came, a lot of jobs created. Now, as you heard that a lot of Google, Ericsson, Nokia is laying out a lot of people. Of course, this is also the inflation in the world because of certain wars going on. Other that is impacting now. So this all big giant telecom, they are laying off a lot of people. And also this is happening because of COVID, which we just passed to 2 3 years back, because a lot of things are opening now online. So this a new world is coming. So a lot of companies don't want their offices they want shut down a lot of because they have their employees working on the online. So of course that is also affecting your business negatively. But that is both client side and the company side. So overall economically that is depend upon different phases. Like companies are earning a lot, and on the other hand, they keep only the person which is benefit for them, and they're laying off a lot of person because they know that they don't want to use the offices places or people who are working from home. So they are well. So you can see in that sense. And but in 6G now we can see a lot of digital twin robotics are coming. So you can see that we will have a less job for sure for that. But again, the good thing is that when you have the virtual or robotic, we have to pay taxes for them as well. So I think it's good if we have the like we pay taxes, we are earning money. So if robot will work, so I think this is also good idea to put taxes on them. At least your economic will circulate. But again, to create these report, we need human effort. So we need a human effort. But I believe to cut short your answer is very difficult. But my personal belief, it will be not good because we are going toward a lot of digital reporting, information technology, everything happening online. Companies need less people. They hire less people to work. They don't need offices. So from the end consumer perspective, like the engineers, so they need to be bit work hard to enter into that one. But of course, if you want to create your own business company, that is the better way in the next 5 or 10 years because of certain. So it's, I mean, it's depend upon a lot of factor. You have a consumer, you have business, you have your country, you have your political situation around you. You have the prices of oil, prices of electricity. So this is all depend on. But of course, we are not like what we living in 4G and 5G. Things are not going to the right direction. That is for sure for 6G as well. If you talk about economically.
Thank you, sir.
So any more queries?
Thank you. Thanks a lot. Thank you. See you next time. Thank you.
Sir, I kindly request you and all of the participants to turn on their cameras to take a snap.
Okay. I don't know. I'm not able to turn off camera. I think you need to give me permission or something like that. Maybe it's too many participants. That's why.
Sir, I think you will be able to turn on the camera now.
Still not. I'm trying, but this Google Meet not allowing me.
So, okay, sir, we will proceed with snap like this.
Okay.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir. Bye.